And good day pre-algebra. We are going over CO43, which is using probability to calculate the odds of an event. The odds of an event. So we've talked about probability before, okay? We start by revisiting the definition, or more so the formula. What is the formula for the probability of an event? I'll give you hints. The fraction, right? To find the probability, what are we calculating? Lily?
Successful over.
Okay, so the probability of an event as a fraction is successful outcomes over possible outcomes. Right? We use that in CO40, I think it was. Okay? We figure out how many outcomes we want to happen, divide that by what could happen, and that gives us, as a percentage, the probability of the event occurring. Okay? Odds do something a little bit different. Whereas probability is set up as a fraction, odds are set up as a ratio. And who could remind me what a ratio compares? Yeah. Good. A part to a part. So the parts that a ratio compares, the parts that odds compare, it compares the successful outcomes to unsuccessful outcomes. Okay? So it's not written as a fraction, so it's not a part of a whole, right? Probability formula, successful outcomes is a part divided by the possible outcomes, part and whole. Ratio compares part to part, successful to unsuccessful. It tells you how many you want and then how many you don't want, instead of how many you want over what could happen. Okay, so you have a standard 52 card deck. Are we all familiar with decks of cards? This is kind of some prior knowledge that I know you are.
Why?
Yeah, you. Okay, but yeah.
Oh,
yeah,
shoot.
right. So you've got 52 of them, right? Half are red, half are black. There are 4 suits. What are the 4 suits in a deck of cards?
Spades.
Spade.
Diamonds.
Diamonds. Hearts.
And like the leaves.
Clubs, what they call.
Yeah, I forgot about that.
Okay. There are 13 of each, right? You've got the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, King, Ace. There are 4 of each. Okay, have you ever played War? Right? Maybe you have some familiarity with these cards, but in any event, you have a standard 52 card deck. Write the probability as a fraction and a percentage, and the odds of each event occurring. Answers do need to be in simplest form, right? Now, I do help you here by telling you how many successful outcomes there are, in case you aren't familiar with cards. But choosing an odd numbered card, and there are 20 of them. Okay? 4 3s, 4 5s, 4 7s, 4 9s, and 4 8s. There we go. Okay, 20 of them. So as a probability here, let's start there, which remember is successful over possible. What is the probability of choosing an odd numbered card? How many successful outcomes are there? There are 20. Okay, there are 20 odd numbered cards. So the probability of picking an odd numbered card is successful outcomes, 20, out of possible outcomes. How many cards could you pick? Any of the 52. Okay? So as a fraction, the probability is 20 out of 52. Right? What you want to happen, successful outcomes over what could happen, possible outcomes. What is that as a percentage? 20 divided by 52, yeah.
0.3846.
Okay, 0.384. What would we round that to be as a percentage?
38%.
38%. Right? 38%. So we've done the first part here, is writing the probability as a fraction and a percentage, right? Successful outcomes over possible. And now for the odds. The odds compare successful outcomes to unsuccessful outcomes. So successful outcomes, there are 20. How many unsuccessful outcomes are there? How many cards aren't odd? 32, right? So the odds of choosing an odd numbered card are 20 to 32. Now, a couple things to notice here. Notice that both of these methods, the probability and the odds, share this 20. That's part of both of them, right? Both of these identify the number of successful outcomes. The difference is probability tells you how many there are total. Odds tells you how many are unsuccessful. But what do you notice about 20 and 32? They add to be 52, right? If you add the total of successful and the total of unsuccessful, that's going to give you the whole. So there's definitely a relationship between probability and odds. Both of them identify the number of successful outcomes, okay? But then probability tells you the total number of outcomes, whereas odds then tells you the number of unsuccessful. Questions? Make some sense? Okay? All right. Let's look at the next couple here. It says choosing a face card, and there are 12. So with probability, okay, what's the probability of picking a face card? Successful over possible. Gregory.
12 over 52.
12 over 52. That's what this number in parentheses is here. It tells you how many face cards there are, in case you aren't familiar. Okay, so it can help you, right? But the probability is 12 over 52. Successful over possible. What is 12 over 52 as a percentage? 12 divided by 52. Nolan.
23%.
23%. Okay, so to calculate that, you take 12 divided by 52, and that equals 23%. So the probability is 12 over 52, or 23%. What are the odds? What are the odds? What are the odds? Gregory?
12 and 40.
Good. 12 to 40, right? Because there are 12 successful, 40 unsuccessful. Again, notice that 12 shows up in each of them, right? Both methods here, both ways to write this, involve the number of successful outcomes. The 40 comes from, well, if there are 12 successful, how many unsuccessful? We know there are 52 total. 52 minus 12 gives us that 40. Now, it does say answers need to be in simplest form. And so we need to simplify this odds here. How do we simplify 12 40ths? What can we divide out of each of them here? 4. Okay. So divide by 4, and we get 3 10. Which means that for every 3 cards that you pick that are face cards, how many cards will you pick that aren't face cards? 10. Right? 3 face cards for every 10 non-face cards. Do the next one on your own here. Choosing a black card. There are 26 of them. Write it as a probability, as a fraction, and a percentage. And then write the odds. probability successful over possible. Odds successful to unsuccessful. Who's confident? What is the probability of picking a black card as a fraction first? Josie. 26 out of 52, right?
Yeah.
There are 26 successful, 52 possible. So 26 out of 52 cards would be black. As a percentage, we're dividing 26 by 52. What's the percentage? 50%, half, right? 50%. What are the odds? How many are black? How many aren't? Successful to unsuccessful. Gregory.
26 to 26.
26 to 26. If the probability of something happening is 50%, that means there are as many successful as there are unsuccessful, right? It's 50%. It could go either way, okay? Again, notice this 26 shows up in each of them as the successful outcomes. And what's 26 plus 26? 52 equals the whole, okay? Let's simplify that. How do we simplify 26 to 26? What do we have? Divide by 26. Simplified, our odds are 1 to 1, which means for every black card that you pick, you'll pick a red card, right? 1 to 1, 50%. Just as many successful as there are unsuccessful. Okay. Questions on this? All right. You got about 10 minutes left. I'm going to let you get to work, actually. I think it's just it's a double. Look at all this. Okay. Double page here. We're going to save the second page of this for tomorrow. Okay. Start to work on this rest of these here. Choosing a diamond, choosing the 2 of spades, choosing a jack, choosing a red odd numbered card. What does 3 to 4 odds mean? 5 to 1 odds mean? 11 to 5 odds mean? I'm going to walk around, check work, so don't close your binder when you finish until I come around. Remember, it needs to be written as probability, as percentage and fraction, and then the odds. Exactly what we did up in the first 2 examples I want you to do on your page here. I'll come around and answer questions and take a look and see what we see. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? Really? Nothing I have to say? Nothing at all? Nope. Can't even think of one nice thing to say to me right now?
Like a shirt.
I just wanted to use.
I like your
use the
shoes.
button. Thank you.
Oh.
Thank you. All right, that's IMF.